Hello friends, I am here with a very important question for your exam of fluid mechanics and hydraulics, that is Darcy-Weisbach equation for head loss due to friction. For derivation of this equation, let us consider a uniform horizontal pipe with a steady flow. Let the section 1 and 2 are the two sections of pipe as shown in this figure. P1 is the pressure intensity at the section 1, V1 is the velocity of flow at section 1, L is the length of pipe between section, D is the diameter of the pipe, F dash is the frictional resistance per unit weighted perimeter per unit velocity, HF is the loss of head due to friction, P2 is the pressure intensity at section 2 and V2 is the velocity of flow at section 2. Now for derivation of Darcy-Weisbach equation, let us apply Bernoulli's equation at section 1 and section 2. So it can be P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2 plus loss of head, that is H. So here, but pipe is horizontal and diameter is same at both the section, the datum head, that is Z1 and Z2 will be same. Therefore Z1 equal to Z2, and as we assume the steady flow, velocity at both section will be same, therefore V1 equal to V2. So it can be written as P1 by rho g equal to P2 by rho g plus HF. Now P1 by rho g minus P2 by rho g equal to HF, or it can be written as P1 minus P2 equal to rho g into HF. Okay, now let us talk about frictional resistance. It can be written as frictional resistance per unit weighted area per unit velocity into weighted area into velocity square. Okay, so we can write the frictional resistance F1 is equal to F dash into area, that is pi into D into L. Pi into D is the perimeter of the weighted area, so F dash into pi dl into V square. So if we put down pi d as the perimeter, so F1 will be written as F dash into P into L into V square. Now the force acting on the fluid between the section is enlisted below, that is pressure force at section 1 equal to P1 into area, pressure force at section 2 equal to P2 into area, and frictional force as shown in the figure, that is F1. Here you can see that in figure 3 forces P1, P2 and F1 is denoted here. Now resolving all the forces in horizontal direction, we have P1 into area minus P2 into area minus F1 equal to 0. Here we consider F1 is equal to negative because frictional resistance is always acting in the opposite direction of flow. So we can write down it as P1 minus P2 into area equal to F1. So now F1 we have the value of frictional resistance from above formula, F1 equal to F dash PL V square, and also after applying Bernoulli's equation we get P1 minus P2 equal to rho g HF. So we rewrite the equation as rho g HF into A equal to F dash PL V square. So on that basis we can write HF equal to F dash PL V square by A rho into G. Okay, now here we know that weighted perimeter weighted perimeter by area equal to P by A equal to 4 by D, that is hydraulic mean depth. So after putting this value, HF will be F dash into 4 L into V square by D rho G, that is HF equal to F into F dash into LV square by rho G D. Now here F dash is the coefficient of friction. If we have to write equation of head loss in term of friction factor, it will be friction factor F will be equal to 4 times coefficient of friction, 4F dash. So that equation will be HF equal to FLV square by 2GD, okay, where F is the friction factor. Now let's talk about Chezy's formula for head loss due to friction. Okay, in Darcy-Weisbach equation we have derived that HF equal to F dash PLV square by A into rho G. Now let us write this equation in the form of V square. So we can write V square equal to A rho G HF by F dash into PL. Okay. Now V will be equal to under root of rho G F dash into under root of HF M by L. Now here we have area by perimeter, that is hydraulic mean depth equal to M equal to area by perimeter. So on value of A by P will be M. So here we have write as M, and also we note that HF by L will be equal to I, that is loss of head per unit length. So we get V equal to under root rho G F dash into under root I into M. So this under root rho G by F dash will be known as Chezy's constant C, and other under root of HF by L will be I. So V equal to C under root M into I. This is known as Chezy's equation for frictional head loss. Okay, thank you.